Hey YouTube, welcome to Software Interviews Prep, the ultimate guide to help you ace your software interviews. If you are preparing for software interviews, make sure to hit the subscribe button and turn on the notifications to never miss a video. So today we have this problem. It's a reverse linked list. It's a pretty straightforward problem that we have a linked list and we want to reverse it. So basically it's 1 2 3 4 5. It will be 1 2 3 4 5. Sorry, it's 1 2 3 4 5. It will be 5 4 3 2 1. So let's go to the sketch and talk about how we can do it, because we have two solutions and I guess we will do the two solutions and I will say why actually. So basically we have 1 2 3 4 5 and the end result that we want to reverse all of that. So one of the solutions that we can just make just iterate and loop through each one and just make one instead of 1 point to 2 will point to 1. So we have two solutions for this one. It's just iterative and iterate basically through this linked list and make sure that we make we change the actual connection. And I guess we will do that, but this will be a next video. I guess this video we will do a recursion, because by doing recursion it's sometimes because in the future we will work a lot with dynamic programming problems. So I guess it's quite good to train with each other about recursion, because dynamic programming gets most about recursion. So so let's see how we can approach this one. We can start backwards instead of going forward. So basically we recur the recursive function. So basically it will search for the tail, the last element. So basically how it will be like do one. Do we have a next? Yeah, we have 2. Okay, let's continue. Call the function again. Do we have a next of this 2? Yeah, it's 3. Okay, we call the same function again. Do we have a next? Yeah, it's 4. Okay, call the same function again. Do we have next? Yeah, it's 5. Okay, nice. Let's call the same function again. Do we have next? The next here is null. No, we don't have next. Okay, start from here. Okay, delete this connection and make it like that. And this for the next, delete. It has no next actually, because this is deleted. Sorry, yeah. So 4 has no next again, has no next. So the function, the recursive function will say, do we have next? No, we have no next actually. So we delete this one and we'll just make it like that, and we will continue until we reach our own last first element. So let's just go there. In this problem, so basically what I'm thinking about that, we will create first, because it will be a recursive function. When you create a recursive function, the first thing that we want to do, let's think first about the base cases, because we want to have a base cases that our function will stop calling itself when we reach this point, because we don't want our function to endlessly calling itself. So I will just say if I had no hit, it's null, or if there is no hit, then dot next. If there is no head and there is no head, dot next, return head. Okay, and let's call it p, because I will return this p. It's like let's say it's a node, or like let's call it p. Let's p equals reverse linked list, but I will just pass to it head.next, because basically we want to reach the end. And once we reach the end, we will do something like that: head not next dot next will equals head. What that means, basically, for this one, let's see that we reach it until head is 4. So head is 4. That means that I'm passing head.next. I'm calling this function again because I will say that head is 4. Okay, I'll tell you something to make it easier for us to. So we start from the beginning and go to the end, so we can understand it. So I start from 1. So I will say if head equals null, that head equals null, no, head equals 1. Okay, or head.next equals null, return head. Okay, head.next equals null, no, we have 2. Okay, so we call this function again. We go here, we call this function, and we say that right now we give a head.next, which will be 2. So we say that head right now equals 2. Head equals 2. So say if head equals null, no, head equals 2. Okay, so or do we have head not next? Yeah, we have head not next, which is 3. So this if statement is not, none of these two things are true. So I'm calling this function again, but I'm adding to it head.next, which will be 3. So I will go again here, which is head will be 3. I will say, does head equals null? No, head equals 3. Head.next equals null? No, head.next equals 4. Okay, so because head.next equals 4, I will say that okay, let's call this function again with head.next, which is 4. So I will say that head right now is equals 4. So I will say if head equals null, no, we have head. Head.next equals null, no, head.next equals 5. So I'll call this one again with 5. I would say if head equals null, no, but if head.next equals null, yeah, there is no head.next. Okay, so right now p it's equals 5. Right now p is equals 5, and I am saying head, okay, head p equals 5, and this is the old head equals 4 equals, or head equals 4 basically, because when we called the last function that was head was equals 5, okay, it returned us directly head. So basically there is other functions that are quite waiting to the other functions to finish. One of them, it's that the head equals 4, the function directly before it. So it will be, okay, head equals 4, and the reverse linked list return 5. So I will basically say that head dot next, this 4 dot next, again let's say head dot next. What is head dot next? Head dot next is 5. Dot next equals head. What that means, basically, I have 4, and it's 0.25. Head dot next, which is 5. Dot next equals head. That means it will be 4. This is the how it looks. Basically, it will be right now. But if we end it like that, it will be 4. And I will say head dot next equals null. What I am doing here, I'm deleting this relationship, and I'm returning p, which is 5. So basically I'm returning p right now. It's 5 that has next equals to 4, and you will continue to have it 3, 2, and 1. So this is how we solve the problem. Although this is not the best way to solve it, because it's a time complexity of O of n and space complexity of O of n, the best one we will do in the next video, but this solution we went to it because we want to train ourselves about recursion basically. So yeah, this is for today's video, and see you in the next video. But before you leave, make sure to subscribe and hit the notification bell so you will not miss a video.